All right, guys, here we go. 3.3 lecture notes. I got mine in front of me. Make sure you got yours in front of you. We're going to be ripping through this. There's going to be a couple ed puzzle questions as we go along. All right. So, objective and key terms. Okay, identify the role of food chains and food webs. So, we're basically dealing with food chains, simplistic version of a food web, how the energy is going through an ecosystem. All right. Then we're going to have a worksheet on this as well. Gross primary productivity, or GPP, versus net primary productivity, or NPP. All right. That's going to be some complicated stuff that we got to deal with a little bit. All right. So, these key terms are in that document, that living document. I think we're at, how many? I just pulled it up. We are at, we're looking at 63 total words at this point. So 63 words for Unit 1B. Those words are going to be due not today, Tuesday, but a week from today. So following Tuesday, that's test day. So that assignment's going to be worth 63 points. All right, a point per question. Or excuse me, a point per term. All right, here we go. So number one in your notes. So energy flows through ecosystems via movement between trophic levels, which we're going to just decipher in here in a couple minutes, through food chains and food webs. All right, the quality of the energy available is going to decrease for every trophic level you go up. So basically, when you go from the producers to the primary consumers, the quality isn't as good. Going to the secondary consumers isn't as good. Tertiary consumers isn't as good. And basically, the higher you go up the food chain, basically, it's just not as quality of energy, and there's not as much as well. All right, now a food chain, okay, this is going to be number 3. A food chain is a sequence of organisms, each which serves a nutritional source for the next. Now, food chain is a straight line, going from producer, primary consumer, secondary consumer, tertiary consumer. One straight line. That's all that it is. All right, about 90% of the energy, this number 4, is lost at each link. So going from one to the next, 90% is lost. All right, so they talk about a thing called the 10% rule. So going from one trophic level to the next, only 10% of that energy transfers, which isn't very good, by the way. All right, now a food web, this is basically everything. I should make myself a little bit smaller here. Okay, this is basically everybody involved in this whole thing. All right, it's the whole food web, all of the producers and all of the primary consumers and all of the secondary consumers and everything. Food webs are much, much, much more complex. All right, now number 6, what's the difference between them? Food chain, simple line. That's all that it is. A simple line, whereas a food web is everybody involved. So instead of producer, primary consumer, secondary consumer, tertiary consumer, that's a food chain. Now you got 5 producers, 7 consumers, 8 secondary consumers, 2 tertiary consumers, like much more involved in what's going on. All right. So this right here, going just directly across, food chain. Real straightforward. Okay, that is a food web. Much more complex. Okay, so the basic difference is the complexity. Very straightforward, much more complex. All right, now let's jump back to this real quick. So number 7, in a grass field with cows, what is the primary producer? That's number 7. So in a grass, hint, hint, grass field with cows, what's the primary consumer? Or excuse me, primary producer. I said that wrong. Okay, what is producing the energy? All right, answer the question, that puzzle. That would be the grass. Okay, you can see there on the screen, producers, that's the plants. Okay, so you're thinking like the plants, the trees, the shrubs, basically anything that's green, generally, there's exceptions obviously, but those basically, everything's doing photosynthesis, those guys are the producers. All right, now in the same field, this is number 8, in a grass field with cows, what's the primary producer? That's the grass. In the same field, what's the primary consumer? Or what's the first guy to consume something? Hint, hint, it's an herbivore. Answer that in that puzzle. All right, that's the cow. The cow, primary consumer, that's the herbivore, primary consumer. Basically, primary means one, first dude to consume something. All right, now what I want you to do in the blank here, I'm not sure how well you can see it there. Okay, basically where it says first trophic level, what I want you to write in the blanks, I know that there's 2 of them, just simply write producer. Right above first trophic level, write producer. Okay, second trophic level, like is on the screen here, you're going to put those 2 words, primary consumer. That's your blanks there. Third trophic level, secondary consumer. Fourth trophic level, tertiary consumer. All right, that's what I want you to write in the blanks for number 9. Okay, and if you need to, you can pause the video to get all that written in. All right, so in the arrows in the food chain, what do they represent? I'll go back real quick. The arrows are representing where the energy is going. Okay. Typically, the mistake I see is the arrows go the opposite direction, kind of showing like, oh, this guy is consuming that guy. Not what the arrows represent. The arrows represent where the energy is going. Cough, cough, hint, hint. Think about that. Answer that question. All right. Here's a food web. Like I was saying, complexity is the big difference here. All right. Difference between a food chain and food web. We already answered that in number 6, so I'm going to skip that one in Edpuzzle. All right, here we go. So here's basically talking about the 10% rule. So you can see on the very bottom, the producers or the phytoplankton in this garden, they make 10,000 joules of energy, or in kilocalories of energy. All right. If you go up one level or up one trophic level, now you have 1,000. Okay, so 1,000 is 10% of 10,000. All right, if you go up another level to the secondary consumers, now you're dropping again, only 10%. Now, the easy way to figure out 10% is you take the decimal point and you move it over one spot. So like 10,000, move the decimal spot once, now you're at 1,000. If you move it over again, now you're at 100. Move it over again, now you're at 10. So figuring out the 10% rule should be pretty straightforward. So think about number 10 here. If the primary producers create 1 million joules of energy, how much would be available to the primary consumers? Okay, answer that in Edpuzzle. All right, 100,000. All you did, you took it, you moved the decimal point one spot, that gave you 100,000. All right, so next, number 11, how much energy would be available to the secondary consumers? Answer that in Edpuzzle. There it is, 10,000. Because again, you went from 100,000, move the decimal spot, now you're at 10,000. All right, pretty straightforward. All right, so we got that, we got that, we got that. Okay, so that question, we already did that, Okay, so now we're on to number 12. All right, so gross primary productivity. Now, think of gross like a paycheck. I'm not sure if you guys work yet. What you get paid, so like let's say you make $10 an hour. Let's say I made $10 an hour and I work 10 hours. Okay, I would make $100. That $100 is considered my gross paycheck. That is what I'm getting total. Okay, that's my gross primary productivity or gross paycheck. So what it is, number 12. Okay, it's the rate at which ecosystems producers convert radiant energy, radiant meaning the sun, into chemical energy or glucose. Okay, that's the gross. All of it, that's the gross. All right, now net. Okay, let's go back to my paycheck example. $10 an hour, 10 hours, I made $100. Okay, my net paycheck is what's going to happen after taxes. Okay, general rule of thumb, you take home about 80%. So my actual gross paycheck is 100, my net is 80. Okay, gross net. All right, now net primary productivity, this is number 13. This is what the rate at which producers use photosynthesis to produce and store chemical energy. All right, minus the rate at which they use the energy for cell respiration. So for plants, let's say they make 100 molecules of glucose. That's the gross. Okay, cellular respiration is like the taxes, like we we're just saying. That's what they need to use to survive. So let's say they use 20 molecules of glucose. The net would therefore be 80. So you start with 100. You use 20 to stay alive. The net is 80. All right, that's a really important concept to understand. Okay, so ecosystems vary in their net primary productivity. So basically, depending on the amount of life, depending on the precipitation, depending on the temperature, that stuff's going to vary a bunch. All right, despite the low net primary productivity, the oceans produce the most simply because they're ginormous compared to the rest of the world. All right, so number 14, why do the oceans produce the most? Simply because of their vast size, or they're huge, or they're ginormous, if you want to use that word. Your call on the notes. All right, now tropical rainforests, is number 15, have a very, very, very high NPP due to their very great variety and the abundance of the plants. So basically, they just have a ton of life there. Highest biodiversity in the world is in the tropical rainforests. All right, now the planet's net primary productivity, that ultimately determines how many consumers can stay alive. Because the NPP, that is like the amount of energy available to everybody else in the food web. So if that availability starts to decline, there's just simply not enough energy for the dudes on top, so they start to decline, is what's going on. All right. Hope you enjoyed that. Hope you got your notes done. If you need to, go ahead and reverse it. See you guys tomorrow.